So thank you very much for your invitation to this conference, and in particular also to Tsuji-san and all the DO colleagues for organizing it. My name is Stephanie Santschi from the University of Zurich, presenting joint research with Drew Richardson from UC Santa Cruz. We worked on this as a team, also including the digital orientalist's very own Hirohito Tsuji from the University of East Anglia, responsible for translations, and Himanshu Pandey, our computational scientist. Our project technically explores how integrating computer vision and citizen science creates a productive workflow where machine pattern recognition and human contextual understanding enhance each other, like we've already seen with some of the previous presentations. We do this to answer our art historical research question about how landscape prints actively negotiated space between people's spatial imaginary, a geographical reality, and illustrators' artistic convention. In other words, we would like to know how these prints helped the early modern Japanese understand their surrounding geographies and how these experiences impacted the prints. Drawing from the crowd, whose prototype we launched in early 2025, is a digital humanities platform that reimagines how we study historical landscapes through computationally enhanced research. We have developed this platform prototype between August 24 and January 25 as Nippon Foundation funding recipients, combining computer vision technologies with citizen science to explore relationships between Edo period Japanese woodblock prints, ukiyo-e, and their topographical realities. We are registered as a Ritsumeikan University ARC IJAC project. Company's Mapshot helps us to adapt existing georeferring crowdsourcing mechanisms for Japanese prints. And I'm also pleased to report that 1 week ago, I was notified that I'll be receiving future funding from the University of Zurich to implement the platform to full functionality and expand research beyond today's case study. But please keep in mind that today we are presenting a prototype. The representation of landscapes in ukiyo-e prints affected how local people understood the environment and their place in it. Today, we'll concentrate on depictions of Enoshima, a peninsula about 2 days' travel from Edo, today's Tokyo, of course, 2 days back in the Edo period. Here you can see it as an aerial photo depicted on a print from 1797 on a map that shows its relationship to the travel route from Edo. When comparing the different views, we discovered a fascinating chronological tendency. In earlier prints that depict Enoshima from the shore, Mount Fuji tends to appear to the left of Enoshima, while in the later prints it appears more often to the right. Discrepancies like this prompted us to consider how artistic representation relates to physical geography. We argue that in pre-modern Japan, these widely circulated prints shaped collective perceptions of place, creating a shared spatial imaginary amongst illustrators, publishers, and consumers. Our goal is not to argue that central perspective indicates progressive landscape rendition. Rather, we propose that as more visitors experience these places firsthand, spatial relationships in the prints, meaning how viewpoints in the prints relate to each other and to the viewer, increasingly reference topological features more realistically.
I'll be talking about the historical and theoretical context. So the images are, of course, ukiyo-e, Japanese woodblock prints that emerged from Edo period urban culture in Japan. By the early 19th century, landscape had become an important genre, with illustrators like Hokusai and Hiroshige creating popular series depicting famous places, or meisho, throughout Japan. Our research hypothesis is that these ukiyo-e landscapes, while operating within specific artistic conventions, became more spatially accurate, in the sense that as visitor circulation in Japan increased, so did the accuracy of the relationships between depicted landscape features in the prints. Which highlights the print's potential to signify actual landmarks in the topography. This, we suggest, made the prints themselves crucial participants in Tokugawa period citizens' negotiation between artistic tradition and geographical reality. When discussing the spatial imaginary, we draw on Marcia Yonemoto's concept of spatial vernacular, how spatial knowledge was produced and circulated in Edo, Japan. While Yonemoto focused on maps, we extend this to the print's visual vocabularies, recurring visual elements that helped viewers recognize specific places. This notion complements Lorenenzi's research on Meisho, which examines how famous places were mediated through travel literature. We suggest that widely circulated prints played an equally important role in shaping spatial understandings. To contextualize our research beyond East Asian scholarship, we found a useful framework in Henry Lefebvre's triple dialectic of perceived, conceived, and lived space. This helps us understand how ukiyo-e prints mediated between material geography, artistic representation, and cultural imagination. Unlike Western landscape traditions developing in parallel, ukiyo-e did not prioritize linear perspective or topographical accuracy. Instead, these prints employed what we would like to coin as significant topography, depicting features that make places recognizable, but arranged for meaningful compositions rather than mathematical accuracy. Print designers manipulated scale, compressed distances, and selected viewpoints that would have been physically impossible for visual and informational effects. So dealing with these artistic liberties presents unique challenges for a traditional art historical analysis. Previous scholarly approaches have either overemphasized the print's spatial documentary value, overstressing the importance of mathematical alignment to topography, or dismissed ukiyo-e's geographical features as solely derived from literature. And while several digital humanities projects have addressed spatial aspects of Japanese prints, they've largely approached spatial analysis through traditional GIS mapping of metadata. We seek a more nuanced understanding of how these images functioned within their cultural context, not as maps in the modern sense, but as technologies for cultivating a shared understanding of place. For our methodological framework, drawing from the crowd emerges from a commitment to methodological synthesis rather than competition. Too often, digital humanities approaches create false dichotomies between computational methods and human interpretation. Our framework explicitly rejects this division, creating a workflow where computer vision and citizen science complement each other. We tested computer vision algorithms to initially organize our digital corpus according to visual patterns. We then invite citizen scientists to engage with these organized materials, bringing their contextual knowledge to the task of geolocating depicted viewpoints. This approach sets our project apart from traditional GIS mapping in that it analyzes visual content itself rather than just metadata, accommodates multiple possible viewpoints rather than single fixed positions, incorporates the cultural logic of landscape representation, and finally creates a feedback loop between computational and human analyses. So we have a five-step workflow. Concretely, the platform establishes topographical identities for landscape prints in 5 steps, here illustrated on the example of Enoshima previously mentioned. So as a first step, we collect and organize prints with corresponding metadata. We then conduct a computer vision supported analysis, such as feature recognition and clustering, to form interesting groups of images to research. Then, through a distant viewing approach, we identify patterns across time, artistic schools, and even iconographic elements. Then we geolocalize these prints using citizen science. And finally, we return to our research context and contextualize results within the wider literature on cultural developments during the time. We've tested the prototype with around 3,000 ukiyo-e images from the Metropolitan Museum of Art's open access database. Through our collaboration with the Art Research Center at Ritsumeikan University, we will be able to select from over 200,000 digitized images for our implementation phase. To use precise geographical information, we utilize terrain models created from elevation data provided by the Geospatial Information Authority of Japan. Our framework acknowledges the cross-cultural dimensions of this research, a relevant factor, of course, for this conference. All of us are familiar with the issue that most digital humanities methods have been developed for Western materials. Applying these approaches to Japanese visual culture requires careful adaptation and awareness of different representational traditions. This involves reconsidering fundamental assumptions about how space is represented visually and what constitutes accuracy in artistic representation. as well as integrating local data, and we hope that our presentation today demonstrates our cultural awareness and informational literacy in that regard.
So next I will be talking about which role computer vision plays in our project. Our computer scientist, Himanshu Pandey, utilized the pre-trained computer vision models CLIP and SIGLIP, and we tested them, checking how they function on the UKA print's distinctive line work, stylistic color conventions, and compositional strategies that compress or expand space. We made a human-in-the-loop approach when working with these extracted image features, incorporating art historical expertise, and asked, for example, what visual features actually define a landscape in ukiyo-e? How do artists signify specific locations? And these questions do require human expertise. Through this method, we were able to kind of detect or filter the landscape images from our training data set. Let's take a step back. So here I manually grouped images from the Yutagawa school, to which print designers like Hiroshige or Kuniyoshi belong. And you could argue that a certain degree of artistic lineage is even recognizable here between these views, such as the positioning of the horizon or the use of the hills in the foreground as framing devices. I also tried different thematic clusters, here showing you images that contain waves. To me, this revealed distinctive narrative approaches in how the waves were used as devices to guide the eye, and also pointed out that certain waveforms, certain waveforms were adapted almost unchanged across the prints. You can see this kind of triangular wave that I marked. And as previously introduced, chronological clustering uncovered shifts in spatial representation. With a green semicircle, I indicate Enoshima Peninsula's location in all these prints. With the red triangle, Mount Fuji to the left of it, and with the yellow triangle, Mount Fuji to the right of it. While not clear-cut, you can see that there is a tendency to depict the mountain to the right of the island as time progresses, mirroring how it could be seen from the shore. And as mentioned, these are clusters that I created manually. So in the fact that in our initial experiments last fall, AI vision models were able to detect landscapes, but were unable to kind of cluster these views schematically to the extent that it would have been useful for us, demonstrates the continued need for human intervention. Despite their power, AI models face significant limitations when working with historical visual material, particularly struggling with culturally specific symbolism and distinguishing between visually similar but conceptually distinct elements. And of course, there's also the black box nature of these systems, which presents challenges for humanities research, where understanding the reasoning processes is an important result, is as important as the result. And therefore, I'd like to suggest that we should be careful to use AI vision models beyond the workflows where it has shown to be helpful. I mean, it's helpful for general recognition, whether images from large image collections contain landscape features and should be included in our data set. But the interpretation of its features, however, we should continue to involve the human. And going forward, I'd like to also create these clusters kind of in different ways, maybe with a picosphere, but that's probably time for another discussion another time. And next, I would like, therefore, to talk about how we involve actually the human, how we do human interaction via citizen science. We are motivated by the belief that conducting research with and also benefiting public stakeholders is advantageous for both, especially as Japanese prints are so popular among a wide public around the globe. To do this, we use a workflow developed by Snapshot, a company at Hague, also a School of Higher Education in Lausanne, the Polytechnical University of French-speaking Switzerland. While their geolocalization workflow was initially developed for photographs with consistent perspective rules, the ukiyo-e prints employ different spatial logic that require a more flexible approach. And so together with this company, we are working on adapting the geolocalization techniques for historical Japanese prints. And you can access this beta platform using the QR code on the slide. And here are some insights of how the platform works. It allows users to compare the printed images with 3D topological models, positioning prints within the actual landscapes. They can select the print from our digital collection, and here There are some that you see on the bottom of the slide. And when starting the geolocalization process, they can indicate where on the map a hypothetical viewer would have stood and in which direction it would have been looking, like here across the lake. And they can also compare this print with a 3D landscape. They can align the key features by marking equivalent points in both. And with enough points, this calculates the point of the viewer and of the depicted area, including viewing angles and data like that. Here I show a finished alignment. While the viewer is placed slightly too high for an actual person to have been on the ground, the relation of Mount Fuji, island, and beach to each other is relatively accurate. Such data about viewing position and geographical relationships can be analyzed across multiple prints. And by comparing the different artistic representations of Enoshima with actual geography, we have found, as I showed in the mock-up earlier, that the later positioning imagined the viewer was standing on the beach. And this suggests, in my eyes, a turning point where the direct observation become important enough to start impact artistic convention. The pictorial standard started to be transformed by the joint spatial imaginary that illustrators and print buyers started to develop while frequenting these places more often and encountering their depictions more often as well.
This brings us to integration strategies. So both computer vision and citizen science independently face validation challenges when confronted with the multiple realities residing in artistic representation of landscapes. Our innovation lies in their deliberate integration, creating multiple validation pathways where computational results are verified by human expertise, while human interpretations gain consistency through computational patterns. Excuse me. Computational methods excel at processing large quantities of material and identifying subtle patterns across hundreds of images. Human participants bring contextual knowledge, understanding of artistic conventions, flexible reasoning about ambiguous spatial relationships, and cultural sensitivity to non-Western representational traditions. In order for the platform to succeed, we need participants with diverse expertise. In Japanese geography, Edo period history, ukiyo-e artistic conventions, and geospatial technologies. These volunteers will be trained using instructional materials that we created as part of this project. New users begin with a guided tutorial introducing artistic conventions and geolocalization challenges before practicing with pre-verified prints. To sustain participation, we've conceptualized a motivational framework drawing on other successful citizen science projects. This includes a recognition system that credits contributors and transforms task completion into an engaging learning experience. Upon full implementation, the platform would include educational modules and community features for discussing findings, such as a moderated discussion forum and the presentation of highlights. The technical implementation of our prototype will require careful attention to data flow between components. Our plan includes a custom interface that handles communication between the computer vision system and the citizen science platform, with visualizations helping users understand the data. Expert verification provides ground truth for both computational and crowdsourced results.
Let's discuss how we can expand what we learned from our Enoshima case study towards larger scale projects. We draw 4 research hypotheses through which we would like to investigate how prints act as sites of negotiation for spatial imaginary, essentially being components of socially shared spatial visual narratives themselves. We argue that there was a shift towards significant topography in some aspects of landscape representation over time. We argue also that we can find textual and visual evidence of increased travel and tourism in the prints and related documents. We also argue that printmakers combined direct observation with artistic convention, and also that prints served as tools that empowered viewers to conceptualize geography. We would like to enforce that we don't suggest a simple progression towards Western-style realism, as throughout this period, printmakers made deliberate non-mimetic choices governed by aesthetic and cultural imperatives. And this interpretation finds support in an 1831 advertisement for Katsushika Hokusai's 36 of Mount Fuji, where his publisher Nishimura Yohachi wrote, These pictures show the shape of Fuji as it differs depending on the place. It is not always drawn the same. Now the shape is seen from the beach at Shichirigahama, so that would be in front of Enoshima, or the view as seen from Tsukuda Island, and will be of assistance to those learning to paint landscapes. So once we realize our prototype to a fully functional platform, we will be able to leverage the visual evidence for these hypotheses at large. And with this, I'd like to conclude. Drawing from the crowd demonstrates the productive potential of integrating computational methods with citizen science for studying historical visual culture. Our early results, such as the Enoshima case study, reveal how ukiyo-e landscapes should be seen as active participants negotiating space between geographical reality and artistic convention. Together with their producers and recipients, the prints created a shared spatial imaginary that influenced how Edo period Japanese understood their surrounding geography. When computer vision patterns recognition capabilities combine with human contextual understanding, we can document the interpretive nuances at the level of each print, while scaling the analysis to previously impossible or hard to reach levels. The case of Mount Fuji's repositioning relative to Enoshima demonstrates how digital methods can reveal visual patterns at large that traditional approaches might struggle to identify. From a theoretical perspective, these findings enhance existing frameworks. Yonemoto's spatial vernacular gains specificity when we can trace how geographical literacy evolved through visual dialogue as well. Nancy's Meisho studies framework is enriched by evidence how famous places were continuously renegotiated through changing visual representations as well. So we take this discussion into the visual realm. Now that we've obtained follow-up funding, we plan to implement the platform over the next few months. During the summer, I'll present different aspects of this project at the Digital Humanities Conference in Lisbon, German-speaking Japanese Studies Conference in Frankfurt, and the Kusasoshi Digital Humanities Conference in Cambridge in September. Through our approach, we hope that we have managed to show that drawing from the crowd aims to be a methodological proposition for socially inclusive, evidence-based digital humanities able to integrate text and image data, and that it is an effective workflow for combining these close and distant reading approaches, which in combination reveal the true impact of historical information. And with this and this image taken from Enoshima towards Mount Fuji, actually, we would like to thank you very much for your attention. You can see the links, project links and contact info on this slide. And if you're interested in any form of participation or collaboration, we invite you to get in touch via this email address. And we look forward to the discussion round. Thank you so much.